Hey, in this tutorial we're looking at section 8.3 on area under curves. Okay, remember that our area is equal to our integral from a to b of f of x dx, which we write as, we use big square brackets and say capital F of x. So remember, capital F of x is the antiderivative of f of x, and we put our terminals a and b on, and we simply sub in our terminal b into capital F of x, okay, and take away the subbed in value of a into capital F of x. Okay, remember though also that b is larger than a. Okay, so if we've got a little picture here, so we're finding this area here shaded in the black, and our terminals are a and b. Okay, things to note: our areas above the x-axis are positive, areas below the x-axis are negative. Hang on, our areas can't be negative, so we find our area and make it, so that should be positive, and make it positive. Okay, make it positive, okay, because it can't be negative. Okay, this is really important. Okay, if your region is split between a section that's above and below the x-axis, then we need to split the region into parts, integrate them separately, okay, make the negative area positive, then add them together. Because the problem that we get if we've got a situation like this, okay, where part of our region is below the x-axis, well, this area, if we just went from A to B, completely doable. There's nothing that will muck you up, okay, at all. But the problem is, this part, okay, when you work it out, it's going to be negative, and this part's going to be positive, so they're going to cancel each other out, and the area won't be actually correct. So you need to split it and go from A to C, okay, which will be a negative answer, okay, make it positive, okay, then do from C to B, okay, and add your two positive areas together. Okay, so we'll have a look at the two worked examples that there are to have a look at. Okay, so we need to determine the area bounded by the curve y equals e to the negative x plus 3, the y-axis, and the line x equals 3. Okay, so if you draw a little graph of that, okay, what it does is it looks something like this. Okay, we come down like that. Okay, that intersects at 4, though not really actually that important. Okay, and we go through, obviously 0, and we go through 3. Okay, and we're trying to find this area there. Okay, so we're going to integrate, okay, from 0 to 3, okay, of e to the negative x, okay, plus 3 with respect to x. Okay, so when we do that, well, we do square brackets. Integral of e to the negative x is negative e to the negative x. Okay, integral of 3 is 3x. And we go our square bracket, close our square brackets, and we put in 0 to 3. Okay, now we sub in our 3. Okay, we want to do brackets around all this, so we'll have negative e to the negative 3 plus 3 times 3. Okay, close our brackets. Take away negative e to the negative 0, okay, plus 3 times 0. Yep, and now we say, well, we've got negative e to the negative 3, okay, plus 9. Okay, 3 times 0 is obviously 0. E to the negative 0, anything to the power of negative 0 is 1. So we'll have take negative 1, which is the same as plus. Okay, so then we say that we get negative e to the negative 3 plus 10. Okay, and that's all we have for that worked example. So we'll keep moving on to our second worked example. Okay, so we want to find the area bounded by the curve y equals x squared take 1 times x squared take 4, and the x-axis from negative 2 to 2. Now the problem that we've got here is we may or may not have a region that's split between being below and above the x-axis. So we need to check that. So what we need to do is really find our x-intercepts for a start, okay, which is easy because we can just go null factor law. It might be that you've actually got to factorise to get this form first so you can find your x-intercepts, etc. So we can say for our null factor law that x squared equals 1. So x equals plus or minus 1. And we can say that x squared equals 4. So x equals plus or minus 2. So if we were thinking about what our graph's going to look like, okay, well, we know we go through negative 2, negative 1, 1, and 2. Now we see our coefficient of our x to the 4 term. If we expanded this out, it'd be x to the 4 and it'd be positive. So it means we're going to have a shape like this. Okay, so we're going to go down, okay, then up, then down, and back up again. We want that area bounded by the curve and the x-axis from -2 to +2. So we're going to have this area. We're going to have all of this area. We're going to have all of this area. Okay, so you can see that both of these areas are below, okay, and this area is above. So what we're going to have to do is split it into regions. So we're going to have to integrate, okay, x squared minus 1 times x squared minus 4 dx. Well, we're going to have to go from -2 to -1. Okay, we're also going to have to do from -1 to +1. Okay, of our x squared take 1, x squared take 4 dx. We're also going to have to do our integral from 1 to 2. Okay, of x squared take 1, x squared take 4 dx. Okay. Now, I'm just going to do one little thing here and say, well, what you could do, okay, is we know that this region from -2 to -1 is going to give us a negative answer. So what we could do is times it by -1. We also know that our region here from 1 to 2 will give us a negative answer, so we could say that we're going to take it away. Okay, quite acceptable for you to do that. Okay, if you don't, you just need to make sure that when you do this part, you know your answer is going to be negative, so you've got to make it positive before adding it on. Same deal with this one here. Okay, now I'm not going to go through this full process because, okay, what you should be able to realise, hopefully, okay, is this area here and that area there would be the same. Okay, so we simply just have to do one of these, okay, and then double it. So what we're going to do is say, now we will use our sign, but we're going to say -2 times -2 to -1 of our x squared minus 1 x squared take 4 dx plus our -1 to 1 of our x squared minus 1 and our x squared minus 4 dx. Okay, so what we're going to need to do is actually expand out our bracket, so because we can't integrate it easily like this. So we're going to go -2 times our integral from -2 to -1 of, well, we're going to have x squared. Okay, we're going to have -4x squared and -1x squared, so it'll be -5x squared. Okay, it'll be -1 times 4, which is +4 dx. Okay. Okay, and I'm just looking in the textbook there, and they've made a little mistake because we've got to multiply these together to give us +4, but they've actually got +5 in the book. Okay, so there's a little bit of a mistake there. Okay, and we've also got to do the same one here. We'll still get our x to the 4. We'll still get our -5x. We'll still get our +4. A little bit of a shame that they made that mistake, okay, because it shouldn't have really happened. Okay, so now we've got everything that we need, okay, to actually integrate this. So you can see though, even though we've got split into regions, it's not horrible because we actually are using the same function both times. So really only got to do it once. Okay, so we leave this -2 out the front of our square brackets, okay, which means we're going to get x, sorry, that one should be x to the 4, so it'll be x to the 5 on 5 minus 5x to the 3 on 3, okay, plus 4x, okay, and that's from our -2 to our -1, okay, plus our x to the 5 on 5, take 5x cubed on 3 plus 4x of -1 to +1. Okay, so now we've got -2 times by, so we've got to sub in our values now. Okay, so we've got -1 to the 5 on 5, take 5 times -1 cubed on 3, plus 4 times -1. Okay, and we want so all our brackets, and we're going to take away now minus 2 to the 5 on 5 minus 5 times minus 2 to the 3 on 3, okay, plus 4 times minus 2. Okay, now that's all just this first one. So I'm just going to leave that for a second because you can see I'm running out of room. Okay, so we'll just work out what this is going to be first and then we'll focus on that one. Okay, so when we do that, we're going to get our minus 2 times, well, we're going to have minus 1 to the 5. Okay, well, that's going to be our minus 1 on 5. Okay, minus 5, so our minus 1 to the power 3 will be minus 1 times minus 5 will be positive 5 on 3. Okay, take 4. Okay, we've got to take away then. Our 2 to the 5, well, that's going to be 32. That'll be minus 32 on 5. Okay, and then we've got our also got our minus 2 cubed, which is minus 8 times minus 5 is going to be positive 40 on 3. Okay, minus 8. Okay, so when we do that, okay, we're going to do a little bit of work here still. Okay, so that's going to be minus 3 on 15. Okay, plus 25 on 15. Okay, take our 4. Minus 96 on 15 plus 200 on 15 minus 8. Okay, so we're going to have here that we're going to be minus 2 outside of minus 3 plus 25 is going to be 22 on 15. Okay, minus our, it's going to be 60. So we had 22, take 60 is going to be our minus 38 on 15. Minus, well, we've got minus 96 plus 200 gives us 104. Okay, and then we've got to take away another 120. Okay, so that's going to give us minus 16 on 15. Okay, so when we do that, we've got minus 2 times our minus 38 on 15. Take 16, which is going to be on 15, which is going to be minus 54 on 15, okay, which is going to give us positive 108 on 15. Okay, so that's going to account for both of these areas. Right, now I better switch colours here because I'm starting to run out a bit of room actually. Okay, so we might just separate this a bit, okay, and try to fit it in this one. So we're going to have 1 to the 5 on 5 minus 5 times 1 cubed on 3 plus 4 times 1 minus 1 to the 5 on 5 minus 5 to the times negative 1 to the 3 on 3 plus 4 times minus 1. Okay, so we've got 1 to the 5 is 1 on 5, so we've got 1 on 5 minus 5 on 3 plus 4 minus 1 on 5 plus 5 on 3 minus 4. Okay, so this is going to be 3 on 15 minus 25 on 15 plus 4, or if you like, now 60 on 15 minus negative 3 on 15, okay, plus 25 on 15 minus 60 on 15. Right. So we're going to have here, we're going to get down to our minus 25 plus our 60 is going to be 35 plus 3 is going to be 38 on 15. Okay, we're going to have positive 22. Okay, take away 60 is going to be negative 38, and we're going to add 30. It's going to be double negative, so it'll be another plus 38 on 15. Okay, which means we're going to be at 76 on 15. We're going to add in our 108 on 15, okay, which is going to give us an area of 184 on 15 square units. Hey, so look, hopefully my arithmetic was fine there. Okay, it's a little bit of a shame when the wet example was wrong and they made that silly mistake of making it plus 5, not plus 4. Okay, so that kind of wrecks everything else. So hopefully all this arithmetic is okay. Okay, generally speaking though, look, the process isn't too bad. Okay, you just got to make sure that if you've got areas below the x-axis, okay, find the area of those regions, okay, make them positive, okay, and then add them to it. Okay, so we're just splitting up our region. Okay, this is just arithmetic. Don't get too bogged down in that. Okay, if you were doing this, you just do that with your calculator anyway to finish it off. Okay, and also your calculator will be able to do these for you as well. Okay, you've got the integration button on there that it'll have a square down there, a square up here, a square there, and then it'll be a d square. Okay, so all the squares you can fill in with your terminals, what your function is, and what variable you're integrating with respect to. So it's something that we can definitely do on our calculator. Okay, so make sure you get your head around these questions, have a really good crack at it, because there'll definitely be something along those lines on an exam.